All right, and welcome to inverse variation. Now, in this, we're going to talk through different types of inverse variation, and I'm going to try and give you a 3 to 4 step method in order to tackle these problems, and these should be pretty easy. So the first thing we want to talk about is just the phrase that you're going to encounter. It says the frequency of a wave f, so they're going to give you the variable, that's very nice, varies inversely with the period of the wave p. So let's just go ahead and write this. Let's write f varies inversely, kind of abbreviate that, with p. All right, well, the first letter that you encounter will always be your dependent variable. And the second letter, or the second variable you encounter, will always be your independent variable. All right, so this is going to allow us to create the general form. So for step 1, I just want you to write general form. And you always take your independent variable, in this case f, and you say, okay, my general form, f is equal to k over my independent variable, p. And this k is very important. That's going to be what we call our constant of proportionality. All right, we'll just call it constant for right here. All right, so that's step 1. We write the general form, f equals k over p, or the dependent equals k over the independent. All right, let me pause this and clean this up. Okay, now this brings us to step number 2. And step number 2 is we actually want to find the constant k. All right, so let's just go ahead and write that. We want to find what k is. Okay, and in order to do this, we always have to look into the problem and find out what are the specific numbers that they give us. It says write the equation that best models this scenario when the frequency is 300 cycles per second and the period is 6 seconds. Okay, so they tell us the frequency is 300, so I write 300 in place of f. And then, of course, we're trying to find k, so we don't know it, and our period is 6 seconds. Now, finding k here is relatively simple. All you have to ask yourself is what is preventing k from being by itself? And the answer to that is it's being divided by 6. Well, what's the opposite of dividing by 6? We want to multiply both sides by 6, and 6 times 300 is, of course, 1800. All right, and so that is going to be our k value. Now, let's just call it step 3. We'll give it its own individual step. Step 3. Let's write this. Let's say write the specific function. Okay? And your specific function is going to be this. It's the frequency from our general, so we write f equals, but here we actually want to plug in k. And so I know that my k value is 1800. All right? And of course we'll divide that by the period p. So this is our specific function, and that's actually what we're going to write for letter A. We'll say, you know what, f is equal to 1800 over p. Now from here we want to go ahead and answer part B. We want to answer part B, and this will be our 4th and final step. And so let's just call this 4. Let's say this is the evaluate step. All right, so we take our specific function, and letter B says how many cycles per second? How many cycles per second? So we are asked to find f. Will the wave have over 18 seconds? And of course the 18 seconds is our p. All right, so we'll say this. F is equal to 1800 divided by 18 seconds. And you can use your calculator, or hopefully you can see that clearly here, f at 1800 divided by 18 is 100. And we would say this 100 cycles per second. All right? And there's your answer. So the answer to part B is 100. All right? And let me circle the part of A that is the correct answer. All right, I hope this was helpful. Let's move on to a second example just in case you need it, and then I'll turn it over to you guys. Okay, for example number 2, we have the amount of force F, okay, the amount of force F required to move an object with a lever of length L varies inversely. So remember, your very first variable that you encounter is the dependent. So let's say f is equal to k over our dependent variable L. Now I like to use a cursive L just so it doesn't look like a 1. Okay, so remember that was step 1. Step 1, let me just go ahead and label that. That was to find the general form. Okay, now for step 2, we know that we want to find k. So let's see, how would we do that? Well, we take the individual parts that we know. It says write the equation that best models a 500 Newton force. So for an F, we can put 500 equals applied to a 3-meter long length lever. So we'll put 3. And of course, we're still trying to find K from our original function. Okay, and in order to do this, well, let's see here. So we know that K is being divided by 3. Well, what is the opposite of dividing by 3? And of course, that is to multiply both sides by 3. Okay, and this brings us to step 3. For step 3, we have our, let's finish this first part. 3 times 500, we can say that K is equal to 3 times 500 is 1,500. So there's our constant. Okay, so the next part is we want to write our specific function. And for our specific function, we go back to our general function here. And of course, we're going to write this. F is equal to some value of K over L. But remember, we know what K is. K was 1,500. All right. So step 1, we write the general function. Step 2, we find K. Step 3, we write our specific function. And that actually gives us the answer to A. So say, okay, you know what? F is equal to 1,500 over L. And this brings us to step number 4. Step number 4 is the evaluate. Let's see, help if I spell this correctly. The evaluate stage. And it says how much force would be applied to a 6-meter lever. Okay, so we can say force is equal to 1,500 divided by 6. And in this case, I would suggest a calculator, just because this could be a little bit trickier. And 1,500 divided by 6 will, of course, give you 250. So it would say that the frequency here is 250 cycles per second. All right, I hope that this helps, and I'll catch y'all in our next video.